Hello students and friends. In this video I'm going to discuss and solve question number 4 of the specimen paper or the sample paper of the subject code 9701, which is A-level chemistry, and the paper variant is 4. So, and in this question we are going to have questions from organic chemistry as well as questions from C13 NMR and the proton NMR. So these topics are really important for the students. So and I have given the detailed discussion of the answers, and I have already written down the answers so that I am able to complete this video in a very short time. So that will save your time as well, and you will get the full understanding. So please stick around with this video, and if you like the video, please give it a like and share it with your friends and subscribe to my channel. Thanks a lot, and let's continue with question number 4. 4-nitro-methylbenzene can be prepared via an electrophilic substitution reaction as shown in figure 4.1. So methylbenzene is converted into 4-nitro-methylbenzene via this pathway. You need, in the first step, you need concentrated nitric acid and concentrated sulfuric acid. As you know, this is a nitration step, and the NO2 group gets substituted at the number 4 position, and you will also get a byproduct. So they want you to draw the structure of this byproduct. As you know that the CH3 group is electron donating and activating group, so the substitution takes place at 2, 4 and 6 positions. So 4 position is already occupied, so the other substitution can occur at the number 2 position, which is the same thing as number 6 position. So the other product will be 2-nitro-methylbenzene. Write an equation for the reaction between HNO3 and H2SO4 that forms the electrophile for this reaction. The electrophile for this reaction is NO2 plus, and it is formed by the reaction between nitric acid and sulfuric acid. The products are H3O plus, HSO4 minus and NO2 plus. This is the reaction which you need to learn, and the NO2 plus is the electrophile for this reaction. Describe how the structure and bonding of the 6-membered ring in the intermediate T differ from those in methylbenzene. In your answer, refer to the hybridization, the pi bonding and the bond angles in the ring system. Okay, so if you look at this intermediate, you can easily see that the pi bonding extends over only to 5 carbon atoms, and the 6th carbon atom over here at the number 4 position has only single bonds. So that's one difference compared to methylbenzene. And further you find that these 5 carbons will be sp2 hybridized, whereas this carbon to which NO2 group is attached is having 4 bonds, so it will be sp3 hybridized, and being sp3 hybridized, the bond angle will be 109.5 degree. These are the 3 differences between the methylbenzene and the intermediate T. Okay, so let's go to the B part. Benzocaine is used as a local anesthetic. It can be synthesized from 4-nitromethylbenzene by the route shown in figure 4.2. So this is 4-nitromethylbenzene, step 1, step 2, step 3, step 4, and finally you get benzocaine, in which you find that you have a COOCH2CH3 group, the ester group over here, and an amino group over here. So in step 1, you can see that the nitro group is reduced to NH2 group, which is done with the help of tin and concentrated HCl, which is heated. These are the conditions you will find in your textbook for the reduction of the nitro group. So these are the reagents and conditions. In the step 2, you find that there is an acylation reaction taking place. The H is replaced by COCH3, so HCl will be the byproduct and this will be the reagent. In step 3, you find that the CH3 group has been oxidized into the carboxylic acid group, so you need an oxidizing agent in the form of acidified or alkaline KMnO4, which should be heated. And in step 4, the amide group is hydrolyzed to NH2 group, so you need aqueous acid for this particular reaction. So those are the steps, the reagents and the conditions for step 1 to step 4. We go to the C part, where we have to predict the number of peaks in the carbon-13 NMR spectrum of benzocaine. So once again, I have drawn this, I have just pasted the structure of benzocaine, where you can see how many peaks will be there in the carbon-13 NMR spectrum. So what are the different kinds of carbon environments that you have to notice? So I've numbered the different carbon environments, the first, the second, the third, this carbon of the benzene ring fourth, these two fifth carbons are identical, this sixth carbon is identical, and this is the seventh carbon attached to the NH2 group. So there will be 7 peaks, and that's the answer. Now further, benzocaine was dissolved in CdCl3 and the proton NMR spectrum of this solution was recorded, and it is shown in figure 4.3, and the data in 4.2, that is this, should be used in answering this question, and you have to complete this table. So you are given chemical shifts, you have to identify the environment of the proton, which you can see very easily from the table 1.2, which is in this range. So it is the alkane, which is CH3 or any of this, and then the next chemical shift which is there at 3.5. So just look at the table once again, and you see this is 3.5, it lies in this range, so it indicates an alkyl group next to the electronegative atom, and so this will be the environment 5.5. So once again, look at the table and identify the 5.5, which is this, in this range. So it could be an NH2 attached to the benzene ring, which is already there in the structure of benzocaine, and then you have to identify the number of hydrogen atoms responsible for the peak, which you can easily find out from the structure of benzocaine, how many protons are there for each of these peaks. So that answers the question. And splitting pattern, this is called as a triplet, this is called as a quartet, this is a singlet, and this is a multiplet. So that answers your question. And then we go to this part, where we have to once again find the reagents and conditions. So benzocaine can be used to synthesize the azo compound. This is the azo compound, and this is the root. And you know that for the coupling reaction, we need to convert the NH2 group into the diazonium group, and the diazotization reaction involves the use of NaNO2 and HCl. Of course, it is at a low temperature of 0 to 5 degrees Celsius, but they have not asked that. So this will be the reagents required to convert the amino group to the diazonium group. And then after the diazonium group is formed, then it had undergo the coupling with phenol under alkaline conditions, and the coupling takes place at the fourth position, which is least hindered, and therefore a coupling reaction takes place over here at the fourth position relative to the OH, and the triple bond changes into a double bond as one bond shifts to form the bond with the phenol ring. And though that is the simple answer. So that completes all your questions of question 4, all the sub questions. Hope you understood very well in the shortest possible time, and please like and comment on the video. Thanks a lot.